doing math with RHB, and we're looking at lesson 23, which is greatest common factor, how you find the greatest common factor. I'm going to turn on my overhead. You won't see much of me, but you can still hear my voice. Greatest common factor, you're looking for the largest number that will divide evenly into all the examples that you're given. So we're going to look at two methods. The first one's the factor method, and the second one's the repeated division method. So look at the factor method first. And I've already done written out all the factors. We did factoring already, so we have an example of 18, 30, 48. We need to find the greatest common factor that goes with all three of those numbers. So we have 1 times 18, 2 times 9, 3 times 6. So all the factors has to be even numbers that go into, not even numbers, but numbers that will go evenly into your example. You cannot have decimals or fractions or anything like that in this case. 30, 1 times 30, 2 times 15, 3 times 10, 5 times 6. Those are all the possibilities multiplied together that will give you 30. 48, 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So we need to find the number in these three examples that is the greatest common factor. 1's not going to work because everybody's going to have 1. 2 sometimes it might be, but in this case we're higher. 3, there's a 6, 5, 4, there's no 5 or 4 here. 6 is the next one. There's a 6 here, there's a 6 here. Is there a higher one? 9, there's no 9. 18, there's no 18. So we've kind of run out of numbers. So in our case, 6 is it. We're going to circle the 6. Down where it says greatest common factor, the greatest common factor is 6. And hike it up and do the repeated division method. Less used, a little more confusing, but the repeated division method, which we covered in another lesson when we were doing factoring. All the numbers to the left of the bracket here all have to be prime numbers. And you keep writing until you can't get any more examples where a number will fit evenly into the others. So 2 into 30, 2 into 60, you'll have 30. The page is going. 2 into 84, you're going to have 42. Again, any number down here has to be a prime number, which is why we did some of the lessons in the order that we've done. We've done some of them so that you have done prime numbers and composite numbers before we get to repeated division methods. We need a prime number that will go evenly into 30 and 42. So we'll try. 2 would work again. 3's a little higher. So we'll go with 3. How many 3's do we have in 30? 10. How many 3's in 42? We have 1, 4, 14. Our last number, and I've already bracketed it out in my lesson, so therefore we know it's going to stop there. What prime number will go evenly into 10 and 14? 2. So underneath all this, you're going to end up with a 5. And 2 will go into 14 7 times. So you've run out of examples here. You can't get anything that will go evenly other than the number 1, which is not a prime number, into 5 or 7. So we have to look at all our numbers here. 2, 3, 2. So I already gave us 2 at the beginning. To find the prime number from the left of the equation, we're going to take the numbers here. And I got those numbers here. I'm going to move them over a little bit. These numbers here are the prime numbers from here. Multiply it out. 2 times 3 6. 6 times 2 is 12. The greatest common factor of 60 and 84 is 12. Sometimes you can figure it out just by doing it in your head. And sometimes as the numbers get larger, you can't do that. We're going to look next at least common multiple, and that'll be lesson 24.